Hello everyone, welcome to our new lecture of discrete mathematics. In this lecture, we are going to solve some example of Poisson distributions, discrete Poisson distribution. So let's see our first example. So in our first question, it is said that in a software company, the company detects on average $5 in every month. What will be the probability of detecting exactly $7 in a month using Poisson distribution? Right, that means we know that the company can detect exactly $5 in every month on average $5. Now we need to find what is the probability of detecting exactly $7 in a month. So if we look at the formula of Poisson distribution, the formula is e to the power minus lambda into lambda to the power k. So lambda to the power k divided by k factorial, right? So here what is this lambda and k means? What does this lambda and k means? That this lambda is the mean or average, whatever you say, mean or average, right? So this is all lambda. So in this question you can see that it is given that the average is 5. That means lambda equal to what? Lambda is 5, and this k is exactly how many we want. K is the exact amount. K is the exact number or exact amount, right? So here how many we exactly want? We want 7, right? So that means this k is what? K equal to 7. So our answer will be what? Our answer will be e to the power minus lambda, which is 5, then 5 to the power 5 to the power k, that means 7, 5 to the power 7 by 7 factorial, right? This will be our answer. Now let's see our, you will calculate this and whatever the result is, that will be your answer. So let's see our second question. In this question it is said that in a software company, the company detects on average $5 in every month. That means the average is 5 months. What will be the probability of detecting exactly $7 in 3 months using Poisson distribution? Now you can think this question as the same as it, like it was also said that it detects on average $5 in every month, and what is the probability of getting exactly 7, and it is also saying that the average is $5 in every month. But the trick here is, here we are asking that exactly $7 in 3 months, right? You can see that the average $5 is in 1 month. The average $5 is in 1 month, but now we need $7 in how many months? In 3 months, right? So the average will change, the lambda or the average will be changed, as it is 3 months where the average was according to 1 month. So the lambda will be this 5 into the month is 3 times of this, right? It was 1 month and this is 3 months. That means this is 3 times of this is 3 times of this, right? That means this average will become 3 times of the previous. That means the average will be 5 into 3 equal to 15. So it will be our average, right? And the exact number is 7. That means k equal to 7, k equal to 7. So the result will be what? The result will be e to the power minus lambda into lambda to the power k, lambda to the power k into k factorial, right? That means e to the power minus 15 into 15 to the power 7 divided by 7 factorial. So this will be our answer, right? So the next question, if we see, The next question is saying that in the software company, the company detects on average 5 bugs in every month. What will be the probability of detecting at least 3 bugs in a month using Poisson distribution, right? That means the lambda is what? The lambda is 5, the average is 5, right? So the average is 5. But what is the value of k? K is what? You can see that it is saying that at least 3 bucks in a month, as there is no upper limit. So if we draw a number line, that means let's assume this is 0 1, sorry 1 second. So this is 1 2 3 4 and then dot infinity, right? So we need to find that at least 3 bucks. At least 3 bucks means what? It is from 3 to from 3 to all the way to the positive infinity, right? As there is no upper limit. So we need to find the probability of this, but is it possible to find the probability of this? It's a huge range, right? But what we can do is we can find out this range, right? We can find out the probability of getting 0, probability of getting 1, and probability of getting 2. But what we need to find was we are needed to find this. But as we are finding this part is what? It is the prime, right? If this is our expected, this is what? This is on unexpected or not accepted, right? So this is the prime. That means if we can find the probability of getting exactly 0, getting exactly 1, getting exactly 2, then what we will do is we will add this probability. Let's assume this is e to the power minus 5 to the power 0 by 0 factorial. Then same, there will be e to the power minus 5, e to the power minus 5, 5 to the power 1, 5 to the power 1 into 1 factorial. And then we will need to find what? We will also need to find the probability of getting 2, right? So e to the power minus 5 to the power 5 to the power 2 divided by 2 factorial. Now if we calculate this 3 part and let's sum this 3 part. So these 3 will represent the prime, right? That is what the part that was not accepted. So what we will need to do is we need to subtract this part. We will need to subtract the summation of these 3 from 1. So 1 minus this is what? Our result, right? So 1 minus the summation of getting 0, 1 and 2, summation of the probability of getting 0, 1 and 2. If we minus that from 1, then that will represent or that will give us the getting at least 3. That means 3 or more, right? So let's see this question. In this question it is said that in a software company, the company detects on average 5 bucks in every month. So what will be the probability of detecting at most 3 bucks in a month, right? So the lambda is what? The lambda is 5. Now it is said that at most 3 bucks. At most 3 means what? 0 to 3. 0 to 3 any number, but not greater than 3. So now previously when it was said that at least 3 bucks, that time we needed to find the prime, because these long range we cannot count. But Now the range is very small, it is 0, 1, 2, 3. So the values of k is what? The value of k is 0, 1, 2, 3. So what we will do is we will find the probability of getting 3 bucks, exactly 3 bucks, sorry, getting exactly 0 bucks, getting exactly 1 bucks, getting exactly 2 bucks, and getting exactly 3 bucks, right? Because as it is said that at most 3 bucks, that means exactly 0, exactly 1, exactly 2, exactly 3. Then what we'll do, we'll sum up these 4 and the result will be our total result, right? That means what? E to the power minus 5, 5 to the power 0, 0 factorial, then the 1, so plus e to the power minus 5, 5 to the power 1 by 1 factorial plus e to the power minus 5, 5 to the power 2, 5 to the power 2, 2 factorial, then e to the power minus 5 into 5 to the power what? The last one is 3, so 5 to the power 3 divided by 3 factorial, right? So divided by 3 factorial. So this is what? This is our result, right? Now let's see the last question. Next question, it is said that in a locality there are 75 people. If on average 5 people knows English, what will be the probability of getting at least 72 people who knows English using Poisson distribution? So the lambda is as previous, lambda is 5. But what is the difference between this question and this question? You can see that here there was no upper limit, right? It was till the positive infinity, but in this question it is there is an upper limit which is 75, right? That means we needed to find 72, we need to find 72, 73, 74, 75. So we can actually calculate this easily. So what we will do is we will find the probability for these 4 and we will add up, right? The summation will be the result. So I guess you can find the probability now, so I will leave the rest of the math to you. Now let's see in the next question. In this question it is said that in a locality there are 75 people. If on average 5 people knows English, what will be the probability of getting at most 7 people who knows English using Poisson distribution? That means now we need to find 0 to 72, right? 0 to 72, we need to find this range. This range is quite big, right? It is quite a large range, but if you can see that the number is what? It is till 75, right? Till 75, this is 0, and then let's assume there are some numbers, then this is what? 72, 73, 74 and 75, right? Now we are asked to find the probability of getting this part, but the calculating this big range is difficult. But what we can do is we can calculate this. We can calculate 73, we can calculate 74, we can calculate 75. So calculate this sum, sum the summation of the probability of these three, and then what we'll do, we'll minus it, because this was the unexpected part, right? The prime, as this was the prime. So what we'll need to do, let's assume the probability of getting these three, the summation of the probability of getting these three, that means 73, 4 and 5 gives us x, right? That means 1 minus x will be our result, right? Now this is the last question in this lecture. It is said that in a locality there are 75 people. A person in that locality has probability 0.5 or 0.4 of knowing English. What is the probability that we will get exactly 5 people who knows English? Now, if we look at our formula, it is what? E to the power minus lambda, lambda to the power k factorial, right? This is what our equation. Now we have the value of k. We know that k is getting exactly 5. So k is getting exactly 5. So k equal to 5. But what we don't have the average or the mean, right? We don't know what the value of lambda. So how do we find lambda from this question? Here, if you can see that there are 75 people, right? That means n, the number of people, or n equal to 75. And the probability of a man knowing English is 0.4, right? So the probability of a man knowing English, the probability is 0.4. Now we can find lambda from this n and p. How? Because lambda is equal to n into p. Lambda is n into p. Now we know the value of n, we know the value of p. So what we will do is we need to multiply this 75 into 0.4, and the result will be our lambda. So now we know the lambda, we know the k, so we can easily find out the probability, right? So that's it. Thank you. Best of luck.